about it too. Steve has come up with a EV charging station that does not use electricity from the grid, instead uses natural gas to provide the engine to charge the vehicles. And then it's even got an element, if say you put it in a shopping mall, the shopping mall wants to charge for it, he uses solar panels to power the e-commerce part. Now, I probably butchered that, Steve, so correct any of the errors I have just made.
Mike, and Matt, thanks for having me on. And it's a pleasure meeting you too, David. But yeah, so ultimately we can use natural gas to generate electricity. The nice part of that, and what Mike was referring to, was the potential for using other energies as well. So we can get into a microgrid technology. We can actually tie it to the building, use it as backup. So when, let's say, there's power outages in the area or in that facility or mall or even an office building, do a transfer switch and switch that over to the building and now power the facility as needed based on the power being generated. Or you can actually just continue to keep charging as well. But we're using natural gas to generate electricity. And for those who do not like natural gas, we can use renewable natural gas to generate that electricity as well.
So what is renewable natural gas?
Renewable natural gas is a capturing of methane from either the waste dumps and or even farms. So that methane then is cleaned, processed, and then put back into the network, and then those credits can be purchased, you know, relative to the person that's actually selling those credits.
And the starting point, and give me sort of the lowest one, which is what, charging 2 or 3 cars at a time, is how much?
Oh gosh, they vary based on if it's going to be a trickle charge, an intermediate charge, or a fast charge. But we typically are seeing that more and more people want to go fast charge because time is money. So the faster you can charge, the faster you can get out and start living your day-to-day life, regardless of what it may be. So with that, you know, if we're doing a fast charge or even the super fast charge, we'll probably say that it's going to be somewhere in about for a 360 kilowatt system, it's going to be probably in the $500,000 to $600,000 range-ish. You know, because we don't know the ins and outs of the project, what do we have to tie to? There's a lot of details, a lot of engineering and design. If there's extra work, it could be a little bit more. If there's less work, it could be you know, somewhere between a $2,000 to $3,000 a kilowatt type of scenario.
And certainly this isn't for residential. This is purely for commercial, because I mean, some people's homes aren't worth $500,000, right? So I mean, this is a commercial play, right?
Absolutely, absolutely. And there's also issues with not having enough power on the grid, even in West Michigan. I know Rivian donated chargers to the state of Michigan for the state parks, but because they didn't even have 3-phase, they could only go with intermediate charging.
Matthew?
So essentially what you're doing is basically citing industrial strength gasoline backup generators in places, right? You know, we've heard a lot of talk about the smaller home, you know, natural gas backup generators, but these are bigger ones. And they would allow fast 440 charging, right?
Yes, yeah, it would definitely be a fast charge, 480 volt type of solutions or higher.
And so it's really even, like I say, shopping malls or, you know, other commercial facilities where
office
people
buildings, maybe. Yeah.
Yeah, so one of the things that we even came up with is, you know, coming up with ideas of just doing even an EV charging lounge. You go to a mall, you bring your car to the lounge, and then even at that level, you know, that lounge could be a place that, you know, we can then take you to any entrance or restaurant on the site or any other location within a certain distance. And now your vehicle is charging. We notify you about the status of your vehicle's charging, and then once it's completed, then you get notified, and then we can either bring the car to you and or even look at taking the car or bringing you to the car, depending on where it's at. We want to move that location of the vehicle, even if it's across the way, just so that we can continue to reutilize that charger and maximize efficiency.
So how long would a charge take at a station like this?
Well, that's actually up to the vehicle. So some of these batteries, their capacity is phenomenal. The super fast chargers like the Teslas, I mean, we could probably charge a vehicle in like 15 minutes to a full charge, anywhere between a 80 to 100% in 15 minutes or less.
Okay.
It is battery capacity and how fast can the vehicle allow you to charge itself.
And then, of course, there's the e-commerce element to it. That's where the solar power comes in. Why don't you explain that?
Yeah, so this could be a microgrid. It could be a combination of technologies, battery, solar, and natural gas power generation. So the fact that we can generate power in AC and DC is great because it allows us that flexibility. But then when we tie it to other technologies, we want to keep that technology consistent. So if we're going to stick with DC charging, fast charging, we may want to have some batteries so that we can hold that energy in place and use it as needed. But when it comes to charging, just in the DC mode from the equipment, not solar related, that's the nice part is we have so much flexibility and we can set it up where there's resiliency in the design for the EV charging, or even tie it to the building with the battery, with the solar. There's so many variables and so many ways we can optimize the solution.
Now, I have insider information that I cannot share too much on, but I know that some of his early projects they're looking seriously at are more governmental / municipality kinds of projects versus private malls and things like that. Disclose whatever you feel like there, Steve.
Yeah, there's a couple of projects that we're talking to, specifically municipalities that are interested in fleet type of opportunities for their buses, for their school buses. There's been a lot of money in fleet and or school buses being deployed from the federal government. Even now, with looking at some of these projects with private owners, if we can look at a large enough opportunity, and if it meets the federal criteria as well as the state criteria, we could get anywhere between 50 and upwards of 80% of a project being paid for in total.
Okay.
Sounds like LTU should be looking at this, Matt. I'm thinking, right, for all those EVs over there.
Well, we've got a couple EV charging stations already, but if they're right, and we're going to go to 30% EVs by 2030 or thereabouts,
sure.
Obviously we are going to need a whole lot more at LTU, and a whole bunch of facilities and places are going to need a whole bunch more.
And the nice part of the
go ahead.
The nice part of this also is if it is a private owner, and if they're selling that power, just like something like a Tesla would be, it could be an opportunity to be able to be a revenue stream generator for whoever owns the equipment.
Okay. So where are you in the development of this technology? Do you have a prototype, or are you working on building a prototype, or where?
We're in the process of looking for a customer so we can deploy our concept in total. But this equipment has been around since 1950 when it comes to power generation. So all we're doing is we're taking existing technology that's been advanced over the years, and now we're applying it through different applications. We're making modifications, just like generating power in DC. We're also looking at developing our own DC to DC charger so that we can actually do a complete pass-through from a power generation with DC power into the vehicle. Because when you're generating power in DC versus buying it, let's say, or generating it in AC, you lose about 20 to 30% of efficiency in that conversion. To be as resilient and as clean as possible when it comes to that and get that efficiency.
And as Matt and I know, since we have ITC and GTE and other folks on the show, the grid right now is pretty taxed. And this is before EVs. I don't even know what percent they are, 5%, maybe 10% of the fleet. And like he says, I mean, they want to get, they being GM wants to have an all electric fleet by 2035. Then you're going to have 20 million cars, 30 million cars on the grid. Then what? So, I mean, yeah, that's a real challenge here for the power generators and transmitters that we've already been talking to. So the fact that you do use natural gas is going to really relieve a lot of that angst, I guess, right?
Absolutely. And we're talking to DTE as well, and we've made recommendations that, they could also, this could be a temporary solution. So, even in this brings it to an opportunity so that DTE can upgrade the grid. This could be the solution temporarily until that actually happens.
Okay. So people are going to want to find out more, I suspect. And so what's the best way to reach out to you, Steve?
Probably you can reach me through my cell phone, and that is 248-842-1480. And you can either text me or you can also email me as well at the parent company at Stevan, Stevan.Bratic at Bratic.net, Bratic.net.